Today we have Keeper 8.4, Volumes of Revolution. All right, so just like with our cross sections, we have two situations. Our two situations really take into account what axis you're revolving around. So if you're revolving around the x-axis, you have the first equation, the horizontal axis of revolution, versus if you're revolving around the y-axis, you have the vertical y-axis of revolution. And so depending on which axis you're revolving around determines what variables you use when you integrate. If it's x-axis, you're using x values. If it's y-axis, you're using. All right, so for our first example, it says find the volume of the solid formed by revolving the region bounded by the graph of f of x equals 16 minus x squared and y equals 0 about the x-axis. So first thing I'm going to do is I'm going to graph my region. And so I'm graphing this solid top line of 16 minus x squared. All right, but I drew the dotted line in at the bottom so that you guys could see the revolution. And I think you'll be able to see it a little better when we get to class. But basically, I'm literally rolling this this parabola around the x-axis, and so I'm forming like this kind of like an egg type shape. All right. So once I do that, I can just plug into my formula, understanding that I have a situation of top minus bottom. And again, I'm looking at it and I know that I have the parabola on top, so the 16 minus x squared, and that's going all the way down to the x-axis, all right, because it's bounded by y equals 0. So it's going all the way down to the x-axis. So we have top, which is 16 minus x squared, minus bottom, which is 0, squared with a pi on the outside. All right, and we're going from -4 to 4 because that's our bounds on the x-axis. All right, so cleaning that up, I get pi, integral from -4 to 4, 256 minus 32x squared plus x to the 4th dx. And then integrating that, I get pi times 256x minus 32x cubed over 3 plus x to the 5th over 5 from -4 to 4. Plugging it in my bounds, I get this long, nasty looking expression, and then I'm going to simplify that. And honestly, this would probably be a calculator question, so you'd be able to simply just plug this into your calculator to get a final answer of 16,384 pi over 15. All right, so the next example, it says find the volume of the solid formed by revolving the region bounded by the graph of f of x equals 2 root x, y equals 0, and x equals 9 about the x-axis. So again, I'm graphing out all my pieces. I have y equals 2 root x is that top solid line in the first quadrant. Y equals 0, that's the x-axis. And then x equals 9 is this vertical line at 9. And we're rolling this again around the x-axis. So we're forming kind of like a sideways cup or something like that. All right, so when I integrate it, again, because I'm going around the x-axis, I want everything to be in terms of x. And I'm doing top minus bottom. So our top is going to be 2 root x. Our bottom, again, is going to be 0. Our bounds on the x-axis is from 0 to 9, and so I just simply plug it into my formula. So I get pi, integral from 0 to 9, 2 root x minus 0 squared dx. Simplifying that out and pulling the 4 out of the integral, I get 4 pi, integral from 0 to 9 of x dx. Integrating that, we get 4 pi x squared over 2 from 0 to 9. And then cleaning that up, I would get 2 pi x squared integral, or from 0 to 9, which simplifies out to 162 pi. All right, next example, it says find the volume of the solid formed by revolving the region bounded by the graph of f of x equals 2 root x, y equals 0, and x equals 9. So the same example before, except for this time we're going about the line x equals 9. So again, we have some type of picture that looks like this. This time you see this vertical line through 9, that's what I'm revolving around. So I'm almost like forming almost like a Hershey kiss when I revolve it around. All right, so working this out, since it's going about the line x equals 9, that's almost like x equals 9 is vertical like the y-axis. So I'm going to treat it like it's a y-axis problem. So I'm going to treat it like I'm revolving it around the y-axis, which means everything has to be in terms of y. So my bounds are in terms of y, and the bounds of this region go from 0 to 6. And then because it's the y-axis, I want to do right minus left. All right, so my rightmost point is the line x equals 9. So that's 9 minus my left, which is my curve of y squared over 4, all of that squared. Now working that out, I get pi integral from 0 to 6, 81 minus 9 over 2 y squared plus y to the 4th over 16 dy. Integrating it, I get pi 81y minus 3 over 2y cubed plus y to the 5th over 80 from 0 to 6. Plugging in my bounds, not really worrying about the 0 since I know that's going to go to 0. And then simplifying, again, I'd probably have a calculator to give me 1296 pi over 5. All right, so the previous methods that I showed you were called the disk method, and they were disk because they form solid regions. The next method I'm going to show you is the washer method, and we call it the washer method because it has holes in it, like a donut, or like a washer, if you're familiar with what a washer is with tools. But it's like, usually you see it between like some kind of flat surface and a screw, and you'll see that it like protects the screw and the surface. It goes right between those and it has like a little hole in the middle. So anything that has a hole in it when you revolve, we're going to use the washer method. All right, so for our first example, it says determine the volume of the solid by rotating the portion of the region bounded by the cube root of x and y equals x over 4 that lies in the first quadrant about the y-axis. So I graph my two regions. The red line that you see is the cube root of x, and then the blue line is the line x over 4. And I'm going around the y-axis, so again, I know everything has to be in terms of y. Now, when I rotate this, which you can see in my second picture, I'm getting a funnel type shape, so I have like a hole in my figure. Or in other words, it's not just solid, like it's not touching the actual axis that is rotating around. All right, so when I write out my integral, I'm going to start with my y bounds of 0 to 2. And then, just like before, because we're doing y, we want to do right minus left. But I want to do right all the way to the axis I'm solving for, or revolving around, minus the left piece to the axis I'm revolving around. Because we're revolving around the y-axis, I'm going to do the right, which is 4y when I solve, minus 0 squared, minus left, which is y cubed minus 0 squared. All right, so cleaning this up, I get pi from 0 to 2 of 16y squared minus y to the 6. Integrating that, I get pi times 16 over 3y cubed minus y to the 7 over 7 from 0 to 2. Plugging in my bounds, again, not worrying about that 0 because it's just going to cancel out the 0. And then simplifying this, I get 512 pi over 21. All right, so our next example, it says determine the volume of the solid by rotating the region bounded by y equals x squared minus 2x and y equals x about the line y equals 4. So again, just like I've been doing, I graphed out my two regions. I found where they intersected. And then I envisioned myself wrapping this thing around the line y equals 4. And you can see the visual of it in the second drawing. All right, so again, because we're going around y equals 4, and that's a horizontal line, just like the x-axis, everything needs to be in terms of x. All right, so I need x bounds, which would be 0 to 3. So I have pi times 0 to 3. And then I need to do top minus bottom because I'm going around something that looks like the x-axis. So the top, in this case, is going to be the axis you're revolving around. So that's 4 minus the furthest away one, which is the blue line, which is x squared minus 2x squared, minus top, which is 4, minus the red line, which is x. And then I square that. So this problem right here kind of looks a little messy, and this would definitely be a calculator problem. So I'll simply plug this integral into my calculator, just as I see it. Remember, you can use the shortcut of Shift plus to get the integral symbol, and you get a final answer of 153 pi over 5. Next example says determine the volume of the solid by rotating the region of y equals 2 root x minus 1 and y equals x minus 1 about the line x equals 1. So because x equals 1 is a vertical line like the y-axis, I'm treating it like a y-axis. And so that means that everything in my integral has to be in terms of y. So once I graph out my region, I have my blue line that you guys see. That's going to be the first equation of 2 root x minus 1. And then I have the red line of x minus 1. And then when I rotate it, it's going to look something like this second picture. So again, I'm getting that hole in the middle, so I know I have a washer. All right, now rewriting each equation, remember you have to rewrite them because you want it to be in terms of y. And so when you do that, you're going to do pi times the integral from 0 to 4, because again, those are my y values from top to bottom or bottom to top, however you want to look at it, of the furthest right, which is this red line, x minus, or sorry, y plus 1 once I rewrite it, minus the region I'm revolving around, or the axis I'm revolving around, which was -1. So I get y plus 1, red line, minus -1 squared for the first term of my washer formula. And then the second one, I'm going to do the next piece, or the further left piece, which is the blue. And when I rewrite that, I get y squared over 4 plus 1 minus the axis I'm revolving around again, which is -1 squared. Again, that's a really nasty integral, and I wouldn't expect you guys to do that by hand. So I would simply plug this into the calculator, and once I plug it into the calculator, I get 96 pi over 5.